Okay guys, today we're going to do lesson 18 where we are computing the actual lengths from a scale drawing. So let's look at example number 1, basketball at recess. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents his plan to install a half-court design as shown below. After checking with the school administration, he is told it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. Will the lot be big enough for the court he planned and explained? So let's go ahead and let's underline our questions. So will the lot be big enough for the court that he plans and explain? So we've talked about how we have to explain, and that means using words. And so let's look at what our scale drawing information shows us. It says that 1 inch on this drawing corresponds to 15 feet in actual length. And so if we have 1 2/3 inches, we're going to have a little more than 15 feet. How would we calculate this? We take 1 2/3 times 15. If you haven't yet, it would be good to pick up a calculator that will do fractions for you, and then you can practice putting your fractions in. And I'm going to put them in right here. So 1 2/3 times 15. So we see that this is going to be 25 feet. We're going to do the same thing for the width here. So 2 times 15, and 2 times 15 is 30 feet. So in real life, it'll be 25 by 30 feet. So will it be big enough for the court that he planned? Well, we have 25 by 75. So 25 is big enough here, and 30 is less than 75. So it will fit on the lot that they have that is 25 by 75. So yes, it will fit on the lot. $25 is equal to 25, and 30 is less than 75. And that's a good way just to explain your process thinking there. All right, so that one wasn't too bad. Let's go to the next. Adjust my camera here. So example number 2. Example number 2 can be done a bunch of different ways, and just because you choose to do it one way, it doesn't mean that someone else's way is wrong. And so let's read this first and see what we think the easiest route to take is to solve this problem. So this diagram shown represents a garden. The scale is 1 centimeter for every 20 meters. Each square in the drawing measures 1 centimeter by 1 centimeter. Find the actual length and width of the garden based upon the given drawing. And so let's identify what we're doing. We're finding the length and the width. So we're going to have 2 measurements, and we're looking for the actual, so we're looking for meters. That's the actual measurement. Centimeters is the drawing, and that's what they've given us. So an easy way to do this one is first we have to identify, well, what is the garden? So the garden is where these plants are right here. And so the easiest way I think to do this one is to understand that each one of these is 1 centimeter, and each one of those centimeters represents 20 meters. So 20, 20, 20, and 20. And so if we add all these together, 20, 40, 60, 80, we see that it's 80 meters. And we can do the same thing for the length. So 20, 20, 20, 20, 20, 20, 40, 60, 80, 100, 120, 140, 160. Any questions on that one so far? If you have a question about anything that we go over in the lesson, if you'll put that question in the stream, and then I can answer it for everybody, because you're probably not the only one that's having a question on that. While that is the easiest way to do it, it is not the only way to do it. So we're going to talk about another way that we could solve this problem. This one's pretty easy because you're dealing in whole numbers, but what happens when you get to fractions and decimals is that it gets a little harder to count by fractions or decimals. And so let's talk about if we use an equation. So we could count like we did just now, or we could use the given scale in a standard equation. So standard equation. Remember that standard equation is y equals k times x, and remember that k is going to be the scale. So our scale here is the 1 to 20, 20 being the y value and 1 being the x value. Okay, so that would be 20 divided by 1, which would just be 20. So our k here is 20. And so if we're going to apply that into the equation, it becomes y equals 20. So 20 meters for every 1 centimeter. Remember that that is unit rate or constant of proportionality. They're all the same. So remember that scale is the same as unit rate is the same as constant of proportionality. So y equals 20 times x. And so here we're going to fill in our x values. That's just how many centimeter squares do we have. So if we're looking at the height or this part of the garden, that's 1, 2, 3, that's 4 squares. So 20 times 4. And if we multiply 20 times 4, 4 times 2 is 8. Put a 0 on, and we see that it's 80 meters, which we got here already when we did our counting. So we can verify that. Set it up again to get the other value. 1, 2, 3, 4, 5, 6, 7, 8. 20 times 8. Well, 8 times 2 is 16. Add on the 0. Y equals 160 meters. So that's another way that you can do this. Now, the next way that I'm going to teach you is probably the most difficult to understand, and it is called using scale factor. So this one we used scale. Scale was given to you in centimeters to meters. Okay, notice that the units are not the same. However, when you do scale factor, it's the same unit to the same unit. And so that's important to note the difference between scale and scale factor. And so if we're talking about scale factor in this particular problem, we are looking at the fact that 1 centimeter is equal to how many centimeters in real life. So normally we wouldn't measure a garden in actual centimeters, but we have to do scale factor here, so we're wanting either centimeters to centimeters, so centimeters in the drawing to centimeters in real life, or we would do a fraction of a meter to meters in real life. And we can do either one. I'm going to go ahead and do centimeters to centimeters. And so here we have to know that 1 meter is equal to 100 centimeters. Centimeters are so much smaller, so it takes a lot of them to make a meter. And so if we're trying to figure out how many centimeters are in 20 meters, because it says that our scale is 1 centimeter is equal to 20 meters, we would have to multiply 20 times 100, because we have 20 of them. We don't have 1, we have 20 in our scale. And so we multiply 20 times 100. And so we end up getting 2,000 centimeters. So our scale factor here is 1 centimeter in the drawing is equivalent to 2,000 centimeters in real life. So this is what you are going to be using in some of these problems, is when they call for scale factor, remember that it's the same unit in the drawing to the same unit in real life. And so you have to do some conversions. You might have to Google it if you don't know your conversions, and that's okay to do that. So if I set it up this way, and then we know that we could use the same equation, but this time our K will be 2,000. So if we substitute in, and we've got 4 centimeters here, that's going to be 8,000 centimeters in real life, okay? No one wants to count a garden in centimeters, but if you needed to, that's the way you would do that. Now, if we use it for the other value, Again, K is 2,000 if we're using scale factor. And 1, 2, 3, 4, 5, 6, 7, 8. 8 here, just like we did before. And now in centimeters, it would be 16,000. Which one is the more practical way to do it? We've used 3 methods here. I think for this one, counting is the most practical because you have a visual aid and you're counting by whole numbers. I think the second most practical way is to do it this way, where you're using the scale, which scale is usually given to you in the problem. And then the most difficult way to me is using scale factor, where you have the same unit to the same unit. So same unit of the drawing to the same kind of unit in the actual real deal. All right, again, put a question in the stream if you don't understand any of that. Let's look at example number 3. So a graphic designer is going to create an advertisement for a tablet. She needs to enlarge the picture here so that 0.25 inches on the scale picture corresponds to 1 inch on the actual advertisement. What will be the length and width of the tablet on the advertisement? So our question is, what will be the length and width on the advertisement? So we've got to identify our X and our Y here. So our X value is going to be our scale picture. And so on the scale picture, that was 0.25. And on our Y, it is 1 inch on the actual advertisement. So remember, identifying your X and Y so that you can set up your equation or find your K value. And so if we're trying to find K, remember that is Y divided by X. And so we would do 1 divided by 0.25, or a fourth. So if you have a whole candy bar and you split it into 4 pieces, how many pieces do you have? So your K value here is 4. So that's an important piece of information. So we can use that equation to go ahead and try to figure out how big it's going to be. So again, this is using scale. So we have Y equals 4X. We're going to substitute in one of our values for the width. And when we multiply this out, I'll go ahead and get the calculator out here and show you. So 4 times 1 and 1/8. We see that this number is divisible by 2, so let's simplify. Simplify again, and we get 4.5. And that is 4 1/2. Now here we're looking at inches to inches, so we're not doing any kind of conversions. We're using the same unit already. So if we were looking at this picture, the real advertisement is 4.5 inches on that side. So now we have to figure out how long it is. So same equation. Substitute in this side. So our advertisement is 4.5 inches by 5 inches and is a rectangle. Go back and make sure you've answered the question. Length, width of the advertisement. We have them both right here, and we've circled our answers. Okay. Time for our last problem. So, exercise. Students from the high school are going to perform one of the acts from their upcoming musical at the atrium in the mall. The students want to bring some of the set with them so the audience can get a better feel for the whole production. The backdrop that they want to bring has panels that measure 10 feet by 10 feet. The students are not sure if they will be able to fit these panels through the entrance of the mall, since the panels need to be transported flat or horizontally. They obtain a copy of the mall floor plan, shown below, from the city planning office. Use this diagram to decide if the panels will fit through the entrance. Use a ruler to measure. This part is unnecessary because they give you the value here. And you can take a ruler and measure it if you want to, but 3/8 of an inch. So these panels on the drawing, 3/8 of an inch. We have to figure out how many feet that is in real life. And so the first thing that we're going to do is we want to look at the scale here. So we've got 4.5 actual length to 1/8 of an inch in the drawing. So again, K equals Y divided by X. Which one do you have first? Well, you have the drawing first. The drawing is your X value and the Y is the actual. And so in order to find the K value, we would do 4.5 divided by 1/8. Okay. So 4 1/2 divided by 1/8. We get 36. 36, I'm going to put over 1 just so that we can explain it. So 36 feet in real life is equal to 1 inch on our drawing. However, on our drawing, we don't have a whole inch. We have a fractional part of an inch. So in order to figure out how many feet that is, we would multiply the 3/8 times this scale. So this right here is your scale. Remember that scale may have different units. It's what's given to you in the problem. So let's look at our question here. We've got some information we've already started working on, but let's see what the question is. It says find the actual distance of the mall entrance and determine whether they will fit. Okay, so we've got our scale here that we just calculated. 36 feet in real life is equivalent to 1 inch in our drawing. And we know that our drawing says it's 3/8 of an inch. So 3/8 times 36 and simplify again. So we see that the mall entrance is actually 13.5 feet. Okay, so if it's 13.5 feet and we have panels that are only 10 feet, that's their biggest because they're squares actually, so it's 10 by 10. So will it fit? So yes, the panels will fit. 10 is less than 13.5. That's our reasoning. So next problem is, what is the scale factor? So remember that scale factor is same unit to same unit. So same unit of the drawing, so whether or not that's inches to inches or centimeters to centimeters, and then real or actual. And so instead of working with a combination of inches and feet like we have up here, we're going to take our scale and we need to figure out, instead of feet to inches, we need inches to inches. So if we have 4.5 feet, how would we figure out how many inches that is? Well, we would take 4 1/2. There are 12 inches in a foot, so 4.5 times 12. So 4 1/2 times 12. And so we get 54 inches. I think it's helpful if you put your units there so you don't get confused and lost, especially if you have to stop and start. So 54 inches is equal to 1/8 of an inch. Well, that's not whole numbers because we're dealing in 1/8 of an inch. So how would we figure out how many inches we need in a full inch? Well, if you're looking at your denominator here, how do I get 1/8 to become 8/8? What would I have to multiply by? I'd have to multiply by 8, right? 8 over 1. 1 times 8 is 8. 8 times 1 is 8. And so 8 over 8 is the same thing as a whole inch. So I need to multiply both sides by 8, because what we do to one side, we must also do to the other. And so 54 times 8. On this side, we've already multiplied. So now I'm going to do my 54 times 8 to see how many inches that would be. 432 inches. So our scale factor here is 432 inches, or let's put 1 inch here, is equal to 432 inches, because we want to do our drawing versus the real or the actual thing. So 1 inch is equivalent to 432 inches. Okay, so let's talk about our problem set for today. I'm going to choose a few of these problems. I'm not going to choose all of these problems. It might be helpful for you to go ahead and do them on your paper and then transfer anything to your assessments. If you have to take a picture, make sure it's clear as possible. Make sure your lighting is good and submit that picture into your assessments. Do not put that in Google Classroom. Your notes, you need to take a picture of all pages of your notes. So you will take a picture, you should take 1, 2, 3, 4 pictures for your notes so that I can grade those. That will be an assignment in your Google Classroom also. So what you're looking for daily is you're looking for 2 assignments. You're looking for 1 to submit the pictures of your notes. You're looking for the other one to be your assessments. And you want to make sure that you're getting both of those done by 3 o'clock the next afternoon. So this lesson, lesson 18, will be due on Wednesday at 3 p.m. Lesson 17 from yesterday is due today by 3 p.m. If you need a reset, you need to ask me for that reset before, let's just say, 1 o'clock in the afternoon. Between 1 and 3, it's not going to give you enough time to redo everything that you need to redo. Please talk with your friends. Make sure they're getting their work done. I don't want to have to give them a 0 just because they're not paying attention or think they've got all the time in the world to get this done, guys. You've got to stay on top of your work. I know this is different for us, but let's help each other out, okay? Also, check back on the stream. If you have a question, a specific question about a specific problem, don't just say, I don't understand it, because we can go back and rewatch the video and rewatch the video. You can Google other people doing these same lessons, other teachers, and you're welcome to help each other as well. But don't just say, I don't get it. Be specific with your question. Say, I understand this part, but I don't understand how to get here. And so be specific. Put it on the stream, and I will answer it, and then I will put it on all classroom streams, because all the classrooms are separate. Because if you're having a question about it, there's probably other people also having a question about that. All right. Email me if you need a reset. You know what to do, guys. Have a good day.